This video is going to look at example 9 and example 10 from your factorial notes. So you'll see right from the beginning that this looks a little bit different, maybe a little bit intimidating in comparison to examples 1 through 8 that we saw. But the idea, the definition that we're going to rely on, this idea of factorials is going to stay the same, okay? So just like before, I'm going to go ahead and expand out what is happening in the numerator, look at the factors that are present in the numerator, and also look at the factors that are present in the denominator to really get a sense of what's happening here. Okay, just like before, when we had a factorial, we start with that number that is in parentheses, okay, that value that in this case it's n plus 2. Okay, and then we need to multiply that by that number. So I'm going to kind of use a lot of notation here just to kind of keep track and give you a really super solid visual of what's going on. But if you do this on your own and you don't find that you need to show this many steps, that's totally fine. But I just want to kind of connect this to what we've done previously, right? We're going to take n plus 2 and we're going to subtract 1. Then we're going to decrease that again. So we're going to take n plus 2, and we're going to subtract 2. And maybe just one more. I'll go ahead and say I need to take n plus 2 again and subtract off 3. Okay, and we don't really know, we don't have any way of knowing what n is. We don't know how large this initial number was. Okay, so we don't really know where to end this direction. So to kind of take care of that, we're going to go ahead and say dot, 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 right? This continues. This pattern is going to continue. And just make sure you guys see that that is a minus 3 right there. Okay, so that's kind of what's going on in the numerator. We're seeing something similar in the denominator. But here, instead of starting at n plus 2, instead of starting at n plus 2, we're going to start at n minus 1. Okay, so I take n minus 1, and I'm going to go ahead and multiply that by n minus 1 minus 1. Okay, right? I'm decreasing that next factor by 1, so I have to take 1 away. Then I'm going to decrease the next factor by an additional 1, right? So I'm going to take the n minus 2 or n minus 1 that I started with, and I'm actually going to subtract 2. Then, just to kind of give myself a good visual, I'm going to do that one more time and say that this guy will be n minus 1 minus 3, and we'll tell ourselves that this continues indefinitely. So before I start worrying about what can cancel and what can reduce, I'm actually going to, I'm actually going to simplify these factors. Oh my goodness. So in the numerator, that first factor is already simplified, right? That's n plus 2. That next factor, just to show you guys what I'm talking about, this guy right here, this n plus 2 and then minus 1, I can go ahead and clean that up. I can simplify that to be n plus 1. And then next I have n plus 2 and then minus 2, which I could write as n plus 0, or I could just say that that is n. Okay, that's sufficient here. And then finally in the numerator, I have n plus 2 and then minus 3, so that will be the quantity n minus 1. Before I look at the denominator, I want to kind of talk through what we've accomplished, right? From n plus 2 factorial to this right here, which this pattern continues, we've started with our n plus 2, and we multiplied by that, decreased by 1. So n plus 2 minus 1 is just n plus 1. Then we multiplied by the next decreased factor, which would be n plus 1 minus 1, or just n. Then next it would be n decreased by 1, or n minus 1. Okay, so you can kind of see there that all we've done is we've decreased each factor as we've written out the factorial. So if you don't need that first step that I did, that's totally fine. I just want to give you a visual of what's happening. Okay, so similar thing can happen in the denominator as far as some simplification goes. The denominator starts with the factor n minus 1, followed by the factor n minus 2, followed by the factor n minus 3, and n minus 4, and we can say that that continues indefinitely. Okay, so looking at this, I see right off the bat this common factor of n minus 1 and n minus 1. We talked about earlier that this pattern is going to continue, right? This decrease in the numerator of 1 is going to continue. So what's happening here in this dot, dot, dot is an n minus 2, and then an n minus 3, and then an n minus 4, and so on and so forth. But writing that out or bringing that to our attention maybe makes us feel a little bit more confident in the fact that we can go ahead and reduce or cancel these common factors between the numerator and the denominator. Okay, those are all shared between the numerator and the denominator, so we can divide those out. So what this leaves us with is the product of n plus 2 times n plus 1 times n. And you can choose whether or not you want to distribute that out. If you're in a multiple choice situation, you might need to mash that to a cubic, but for right now, I'm going to leave it in factored form. Okay, so all this work has told me that the quantity n plus 2 factorial divided by n minus 1 factorial is simply equal to n plus 2 times n plus 1 times n. And like I said, you can go ahead and distribute that out if you'd like to and collect like terms, but for right now, I'm just going to go ahead and leave it in factored form. All right, so we're seeing something very similar in example 10. Maybe a little bit more complicated or intimidating looking because we have a coefficient in those factorials, but again, the process and the same idea is going to apply. So we're going to start with 2n minus 1 factorial in our numerator. So we'll take our 2n minus 1 to start, and then we will multiply that by 2n minus 1, but we're going to go ahead and decrease that by 1. So kind of staying with the notation that I was using earlier, I'm going to go ahead and say take that number in the factorial and subtract 1. Then we'll multiply by that number in the factorial minus 2. And just to give myself a nice visual of what's going on, I'll go ahead and do one more and should say that this next factor would be 2n minus 1 and then minus 3. And again, if you don't need this intermediate step, that's totally fine. And I don't quite have room to write it, but we should remind ourselves that this pattern continues. Okay. So in the denominator, we will be starting with the 2n plus 1. And then we're going to go ahead and multiply that. That next factor is going to be 2n plus 1 minus 1, followed by 2n plus 1 minus 2, followed by 2n plus 1 minus 3, and again, that's going to continue. So before I get too much further, I'm going to go ahead and simplify this. And again, if you just jump straight to this step that I'm about to write, that is totally fine. So the numerator becomes 2n minus 1 times 2n minus 2 times 2n minus 3 times 2n minus 4, and again that continues. So all I've done is really dropped the parentheses because I don't have any multiplication happening and combined like terms. Then in the denominator, I have 2n plus 1 times 2n plus 1 minus 1, but I can just call that 2n. And then I have 2n plus 1, but then minus 2, so that will become 2n minus 1. And then the 2n plus 1 minus 3 becomes 2n minus 2. And that will also continue. Okay, so looking between my numerator and denominator, I notice that my common factor actually starts with the first factor in the numerator, right? We start with 2n minus 1 in both the numerator and denominator. So that allows us, by nature of these factorials, to cancel everything else that follows. Okay, all of those factors represented by the dot, dot, dot. Okay, so this leaves us with 1 over 2n plus 1 times 2n. And much like example 9, if you want to go ahead and distribute out that denominator, you totally can, or if you want to leave it in factored form, that is fine by me as well. So this tells us that the quantity 2n minus 1 factorial divided by the quantity 2n plus 1 factorial is equal to 1 over 2n plus 1 times 2n. Okay, at this point you guys have 4 problems, some 4 practice problems that are pretty similar to these examples. So go ahead and try those out and let me know if you have any questions.